Hello and welcome to my presentation about the data science project-based internship program from Rakamin that partners with IDX. Before we get into it, I have the important announcement that important links are placed on the last slide. As for introduction, my name is Bramantyo Nandarsiadi. I am from March 2026 batch. So for further introduction, I am currently a Master of Data Science student from Monash University. I have also attended Gajah Mada University in management. I have an experience as a business analyst from PT Solixmen Technology Indonesia. If you want to get to know me better, you can take a look at my portfolio at this link. Okay, so let's get into the final task of loan credit risk protection. So, as a data scientist at IDX, my job is to create a credit risk prediction model for future borrower for a client in multi-finance using data from 2007 to 2014. And the model will also be used to analyze the risk a borrower has using the relevant data which is in 2007 to 2014. Okay, so first I want to get into the data extraction process. So the works is that the raw file is stored in the MongoDB because MongoDB has a versatile feature that can handle data without us using the schema. And after that, I clean the data from the MongoDB into a clean data that I store back, but in a separate collection. And though that clean data is extracted again using Jupyter Notebook for either and modeling purposes. And now you might wonder, how did I do the data cleaning process? So first I remove the current borrowers from loan status because we don't want to predict people who are currently borrowing. And the second is that I set unemployment status in employment title column, which indicates the null values because null values here means that might be unemployed. And third, I remove the data because they serve no purpose for the modeling and the data analysis part. And the fourth, I fix the numerical data types such as employment length and term. So the term will use monthly numbers instead of yearly because that's how it is used in the previous raw data. And the employment length, I change the 10th plus years into 10 because they are valued the same in the previous row data also. And the rest is I just remove the remaining null values, which is why the end result is that I only have less than 7,000 rows and 48 columns as a clean data, and the one that I use for modeling only has 19 columns. Okay, so let's see the insight after I clean the data. So these are the loan value distribution, which is why in the modeling process, I will use mode in the pipeline to balance out this data. And then as we can see, most data are skewed to the left, which means that most of the data has lower values than the median. And third one, we can see that there is a high correlation between these four columns, which is why I remove the other three and I use only the loan amount because it has the highest correlation towards the loan status. And fourth, we can see that this is the loan grade and loan status, which follows up our assumption that the higher the loan grade, the the more likely they are to fully paying their loan. But if you see here, E has lower chances of fully paying their loan compared to the F grade, which is kind of strange if you think about it. Okay, so now let's get into the employment titles. Most of the titles here we see are people who are unemployed after I input that in the employment titles, which is why I will change the employment titles to employment status if they are to see if they're unemployed and or employed. And if you see here, they are strongly correlated because unemployed people have lower chances of fully paying their loan compared to the employed people. Okay, so feature engineering part is how I use the column to predict. So I use scalar for there are min max to handle the outlier, and then standard scalar to handle numerical data that are normal or have few outlier. Ordinal encoder for grade and verification status, one hot encoder for purpose and employment status. As for the method I use to handle imbalanced data, I use not majority sampling strategy from smooth. Okay, so let's check the model result. So as you can see, these are the model result with the metric evaluation. So total misclassification is simply just the the number of data that is wrongly predicted by the model. Mean absolute error is the ranges of number between the actual one and the one that I have predicted, the differences basically. And the coherence kappa score is the agreement percentage between the predicted value and the real value. As you can see, the one that I use to basically get the middle of the perfection is the logistic regression because it has the lowest chances of being of them being higher to overfitting. The proof of overfitting we can see on the two-efficient matrix. So if you see here, logistic regression has the highest chances of predicting the value of 4 after the smoothing process. Value of 4 basically means that they default, while the value of 5 means that they are charged off, which is worse. However, the logistic regression can successfully predict the value of 4 because which means that they don't have the tendency to overfit the training model that agree with the majority of the data. So because of that, I fine-tune the model of logistic regression so that they can have a better score and lowering the chances of error. As you can see, the result is I have reduced the misclassification chances by 0.5% and also the mean absolute error by 1.1%. I also happen to increase the kappa score up to 98% of agreement, which is the highest among the other model. So yeah, I have successfully created a model that have little to no biases using smooth, and this model also shows how simple model can be useful in a production environment. And the parameter tuning also help reducing the error score, the which is better than the other model. So the improvement that I want to make further is that I probably need more clean data. Yeah, to train the model better. And outlier handlings also need to be improved, not just with scaling. The null values handling also needs to be improved because I only remove the null values from the data, and it has still has a tendency to give the wrong output because of the weakness provided here. So yeah, I think that's all for my presentation. You can see the important links here, which are the GitHub repository and the deployed app that you can also try on experiment on in the browser. So yeah, I think that's all to save the time. Thank you, and I'll see you later.